Welcome back. We left off last time on the analysis of ambient occlusion. Today we are going to move forward by going to analyze shadow capture, and to do that I'm going to propose a practical exercise to do together in which we are going to insert an object inside a photograph. As we can see, we have this mesh casting a shadow on the floor of the square. The scene is very simple. It is a simple mesh, our famous Suzanne, which is not only inserted into the photograph but also casts a shadow on the floor of the square. To achieve this, we will use an open source software called FSPy. You can find it at fspa.io, and you can find it for Mac, Windows and Linux. Once we start it, we find ourselves this very minimalist interface in which we are going to drag the photo in which we want to place our object. This program is used to help us set the Blender camera to be in the same position as the camera that took this photo. If you like, you can download this photo from the link I leave in the description of this video, but still you can use any type of image you create. One recommendation is to have good reference points to go to indicate what the reference axes of the scene are. Let's click on Dim Image to see the photo at its normal brightness, and let's go find out what axes we can indicate to the program to calculate the camera point of view. In the meantime, we have the option of indicating a z-axis that is the vertical line in this wall, and we also have another vertical line in this other wall. We always need at least two. Another good reference point instead are these lines on the floor that will be able to give us, for example, the direction of the y-axis. So we are going to indicate that the axes of the vanishing points are not x and y, but are z and y. In fact, now the colors have changed. We have the blue lines and the green lines. We are going to move the z-axis. Each axis is defined by two segments with two manipulation points. So now I click and drag, and the same thing for the other point. While for the opposite side, we move to this other building. On the other hand, as far as the y-axis is concerned, we are going to pick up two lines of the pavement. Let's go back to show the image at maximum brightness to go and check that we have positioned the segments well, and there we have defined our reference system. If we now click on the origin of the x, y, and z axes by going to move this point to the different positions in the photo, we see that the axes fit the geometry represented by the photo itself. Of course, this is an approximation, but it should be enough to make a photo insertion quite realistic. We can also click on this menu on the left in the 3D guide and, for example, select box. You see there appears a cube that we can go and place in our photo to see if we have done a good job. Once we are satisfied with the definition of the shooting point, we go to the File menu and click Save as to go save our file, which will have a FSPy extension. Let's go back into Blender with a new file, and before we continue, let's make sure we have also installed the FSPy file import add-on. Let's go into the preferences in the add-on section and look for FSPy. In my case, I already have it enabled. If you do not have it, you can always from the site from which we downloaded FSPy go and click on Official FSPy Importer Add-on for Blender. Once the add-on is enabled, all we have to do is go to the Import FSPy file menu and go and select as a file the one we just exported. Blender creates for us a new camera object. In this case, it is called a cc.fspy because that is the name of the file I created. In your case, you will have the name of your file. Then we have our object, the cube, which in this case we can delete. What we are going to do is we are going to insert the mesh that we want to represent, in my case, the monkey head, so shift to monkey. And we move it, for example, here. Be careful, what are we seeing? We are seeing the background photo that we imported thanks to the FSPy file, but we are seeing it because it was set as the background image of the new camera that was created by the FSPy add-on. If we rotate the view within the 3D viewport, the image disappears. So when is it that we see it? We see it when we are in the room view, when we press, for example, the 0 key on the numeric keypad, and it will actually be our render result. Let's remember to enable cycles as the render engine and go into rendered view. We see that the light source illuminates the monkey head from behind. We can, for example, change it by selecting it and clicking in the object data properties and then going to select sun. Let's place a value of 2 as the power and as the slants of the sun rays. We can get help from the shadow on this wall, so let's click on this yellow dot and go to match the shadow line. Of course, then we would also need to see from the side how the shadow is tilted. We press the 0 key again. We have our background image. We have our monkey head, but what is missing is the shadow. Why can't we see the shadow on the square floor? Because there is no object to pick up this shadow, because the image that we see in the background is simply a projection that is applied to our camera object. So what we should do is to insert an object that will capture the shadow, and in our case a plane type object will do just fine, so shift a mesh plane. Let's scale it and see now that the shadow is there. Unfortunately, however, the plane object is going to cover part of the background image for us, and this we of course do not want. How do we go about telling Blender that we only want the shadow of this object? Let's select it. Let's go to the Object Properties section, specifically in the Visibility section, and let's go select Shadow Catcher. Lo and behold, the plane changes color, but we seem to keep seeing it. Actually, what we are seeing is the background, our world object, which in this case is a gray. To get the final effect, we have to ask Blender to make our ambient light transparent, our world. So let's go to the Render Properties section, let's go find Film, that is Film, and let's go indicate to Blender that we want it transparent. So here is where the visibility of our world disappears. In fact, we see this checkered background, and our shadow is now cast on an object that is actually invisible, giving this particularly realistic effect to our scene. So you understand that with this system we can do photo inserts very quickly and also extremely effectively. An example of processing that could take place thanks to this technique is to go and visualize work on the facades of an apartment building, for example for the installation of a thermal envelope. Let's try now to run the render to see what results from this operation. Let's go to the Render Properties section. In the Render subsection, let's go to Indicate Not Noise Threshold, so we'll turn it off. But let's go to indicate a number of samples equal to say 16 while leaving denoise on because it's so few. Because we're really just experimenting now, so we're not interested in having a completely grain-free image. Another thing I would change before launching the rendering is the size of the output. Since by default the FSPy add-on goes to us and changes the resolution of the render so that it exactly matches the pixels of the image being used, we go and tell Blender that we want to render, for example, only 50% of the image. This means that the size will still be 3024 x 1998, but it will be scaled by 50% proportionally. We then press F12 and see what comes out, and here is the result. It is not exactly what we were expecting. Where did the background image go? Well, the image is not there because Blender shows it to us exclusively as a background image in the camera. We have to go in and say we want to display it, and this is really a great exercise in using compositing. So let's close the Blender render window and go to enable the compositing layout. We enable Use Nodes, and we see that the render layer node has only 3 output connectors, and it's specifically missing the shadow catcher connector, which is what we set out to study. So we go to the View Layer Properties section and go to Enable Shadow Catcher. You see it appears, however, I remind you that once you add a new connector you have to relaunch the rendering, otherwise we don't see any results. Let's press F12 again and close Blender Render. As we have already seen in the past lessons, to display in the editor background the image we are producing, we go to Insert an Output Viewer Type node, then we insert the reroute and go to Connected in Viewer. With the V key, we can reduce the size of the image, and by clicking on the Viewer node we have the ability to act directly on the 4 corners to change the size. Well, we have our monkey head, but it is missing both the shadow and especially the background image. Let's go ahead and insert them together. To insert the background image, the procedure is very simple. Just drag the photo we used in FSPI inside the compositing editor. Blender creates the node directly. It is an input node. In fact, it has no connector on the left, and we have on the output this connector called image that we're going to blend together with the output image of the render layer. How do we do to merge 2 images together? We use a color type node, so shift to color alpha over. We're going to place it over the connection line between the image and the reroute. You can see that it turns white. Let's left click on it to confirm. Then we go to connect under the background image. What happens? What happens is that, as we have seen on other occasions when we have 2 inputs in a node that connects 2 images together, the factor value tells us how much of the first image is to be seen and how much of the second image is to be seen. When the factor value is equal to 1, 100% will be seen of the second image and 0% of the first image. Conversely, when the factor is 0, we will see nothing of the second image, but will see everything of the first. We, however, do not need to superimpose the images evenly. We need to make sure that only the part of the mesh is overlaid, and in this case we are going to use the alpha channel to be input into the alpha over node. Let's do this together, and we find that yes, it worked perfectly, but exactly the opposite of what we set out to do. In fact, we see the cropped image only in the outline of our Suzanne. Actually, the solution is very simple. Just reverse the two image connectors, so we will put the one below in place of the one above and vice versa. So here we have our Susan superimposed on the picture, however something still doesn't add up. If you notice, Susan wasn't that small because the image that we put now in our node system is a full-size image while we created a 50% rendering. So we will have to make sure that we reduce this image to match. This is easier to do than to explain. We insert a new node with Shift A, go to the Distort group and select Scale. This node is for scaling RGB type information, images in a nutshell. We're going to put in the connector that connects the image with alpha over, then we're going to select from the menu instead of relative render size, that is, we're asking this node to scale the input image with the exact same number of pixels that we set when rendering. This will also allow us to later vary the size of our render so much we will know that there will always be this node to correct the scale automatically. Here we now have Suzanne at the correct size again because we have actually shrunk the background image. However, we notice that this famous shadow is still missing. Where did this shadow go? We find it here in the output of the shadow catcher connector. With CTRL Shift, we click on the connector to go and see what the output from shadow catcher is. It is an image representing Susan's shadow. Well, now we are going to use this shadow to go and project it along with the rendering and along with the background image. Let's insert a new node with Shift. Let's go to the color group and select the mix node this time. The mix node works like layers in Photoshop or GIMP. If we click in the mix menu, we see that we have different types of blending between the input elements. For example, we have multiply, color, saturation, and so on. In this case, we try with multiply, and as input we go to enter shadow catcher, and now we have our shadow as well. This is a practical compositing example where we went to use the shadow catcher type information to create a realistic photo insertion. Well, that's it for this lesson. If you have not already done so, I invite you to subscribe to the channel. As always, I thank you for following, and I will see you again soon.